Well, good afternoon, everybody. It's a pleasure to be with you. Nice full room. I suspect you're all here for me and not for Edward. So I just wanted to spend a quarter of an hour, 20 minutes or so, really as an extension to last year's talk that I did, for those of you that are here, really to share with you what originated as internal engineering material that we were using at Symantec to really think through what we were up to as a security company. It kind of struck me in going through this content a few times internally that there's some things in here that I think are relevant and appropriate to all of us, both in terms and in context of some of the things that we're suffering from in security strategy, the things that we're really struggling to get our heads around and our budgets around, quite frankly, but also then how that probably needs to manifest itself in terms of innovation in the industry. It's my observation of the past decade or so, working in cybersecurity and cyber defense, that I work in an industry that has been iteratively innovating. There's definitely a lot of innovation going on in the industry. If we look at any of the vendors in the industry and what they've done over the past decade, we've seen lots of good work going on, lots of sort of leaps forward in terms of the ability to defend our businesses from cyber attack. But in my mind, there's been nothing particularly radical. We've seen incremental innovation. The issue there is, I think that's lost pace with two factors. Number one, the criminal. If we look at what the criminals have been doing over the past decade, and you compare the nature of a cyber attack to a typical enterprise 10 years ago, and you compare that with some of the things we've seen in the last 12 months, the innovation in that area has been nothing short of amazing and radical. Not least of which, if I think about the way these criminals are communicating with one another, sharing best practices and sharing ideas. We're not very good at that in cybersecurity. So, and then the other factor being IoT. I'm going to use just IoT as a generalism. The pace of digitization in business, the race to digitization across every vertical market that we see in the world, I think is outstripping pace of the innovation going on in security. And both of those factors, the criminals themselves and the pace of digitization, is creating a gap. And it's that gap where we see some of these really horrible breaches occur. And we see businesses really caught unawares, and in many cases, unaware for a good period of time before they're made aware of an attack. I was talking to a bank recently. We've done some research that backs this up, which would suggest that somewhere between 200 and 250 days is the amount of time for a mature enterprise organisation to realise there's been a breach. 200 to 250 days. Then they react, then we kick into remediation and that kind of stuff, right? Way too late. By that time, the damage, of course, has been done. That talks, I think, to what I'm speaking to here, right? A massive gap between what's required and what's actually happening in the enterprise business today. So I'm going to start today by talking to you about a few issues that we think are driving this need for radical innovation in the industry. And I'm going to start with finance. So if you talk to any of the CISOs in any of the businesses across vertical markets today, if you talk to CIOs and the business themselves in some cases about security budget, what they'll probably tell you is that security have got it pretty good. They're getting somewhere between 4 and 8% increase on their security budgets year on year. Frankly, the envy of the rest of the IT organisation. That's pretty good. At least they're getting some money. They're getting more money than they got last year. Unfortunately, because of some of the other challenges that we're going to mention here, it's not even close to being enough. A 4 to 5 to 6% increase in security budget might just be enough to do some of the sort of keep the lights on and annual security improvement stuff that we're all going to have to do anyway in order to try and stay ahead of the game as we can. When we layer onto that things like regulation, I'm not going to mention the 4-letter acronym because you're bored of that by now, right? But regulation, whether it be that one or other ones, right? They are new projects. They require new funding, new architectures, new ideas, new resources. Then we layer onto that the incredible shortage of security labour. I was working in Saudi Arabia recently, and I was talking to a security architect, an enterprise architect in security. He's being paid, and he was quite happy to tell me this for obvious reasons, he's being paid close to $750,000 a year. as an enterprise architect in Saudi Arabia. Now, not everybody wants to work in Saudi Arabia. You go there if you want the money, okay? But that is an indictment of what's going on in terms of labour in the security industry today. Exactly the opposite to where I was when I was 20 years old. There are now 100 jobs to every applicant. Finding good quality people is very, very hard, and that's driving labour cost up. And then you layer onto that this thing here, more and more of the security technologies that we're consuming being subscripted, as opposed to the traditional perpetual license. And of course, that itself is being driven by the innovation around cloud. So as we move to cloud architectures, as our businesses embrace cloud more and more, and my experience of that is kind of two kinds of customers. There's what I call the box of frogs customer. That's most of them. The box of frogs customer, this is you open the box, the frogs jump out, very hard to get them back in again. That's the box of frogs cloud strategy. That's typically a business that's been dragged into cloud by its users. So its users started using fundamentally brilliant file sharing applications and things of that nature. These became unsanctioned used applications, shadow IT, we sometimes refer to that as. And now these businesses are panicking, driven by, again, regulation and PII to try and get those frogs back in the box. The other kind of customer is the one that's pragmatically thinking about how are we going to adopt cloud. Both of those types of customers, though, are now moving to a world where they need to maintain, from a security perspective, dual environments. We now have the on-premise stuff that we've had for years, and we've got all this cloud stuff. Some of it's good, some of it's bad, some of it's somewhere in between, some of it's sanctioned, some of it's not. But there is extreme paranoia over how resilient and secure are those cloud infrastructures. And there's also things to worry about in there, and we'll talk about this a bit later, like shared responsibility. If I'm going to host my critical applications in an infrastructure as a service environment, even one of the big ones, who's looking after my data? Is that me or is that hoster? Well, I can tell you in most cases it's you, whether you know it or not. So this is creating enormous problems again with budgets. You add these things up and we've got a budget problem. Second thing I want to talk about is a dark internet. So, you know, I've been in security long enough to remember when security and encryption in particular, encryption was nothing but good. It was nothing but good. We definitely wanted it. It was the most exciting thing we had available to us. It allowed us to encrypt our network packets and stop nasty people looking at those packets, and it allowed us to be very, very confident with what we were sending and receiving. Well, encryption's still our friend, but of course it's also the criminal's friend. If the criminal can find a way into those encrypted packets, they can send bad things to us that are encrypted, which bypass, in most cases, traditional security technology. So encryption is both a friend and an enemy at the moment. And in case you hadn't noticed, more and more of the internet is becoming encrypted. We estimate somewhere between 70 and 90% of the network traffic that your business will typically see day to day will be encrypted in some way. Now, there are big forces at work here. If we think about some of the massive Goliaths in internet, you know who I'm talking about, they are very reliant on advertising revenue. And advertising revenue can be very effectively protected with encryption. So there are forces in this world that are saying, well, this encryption stuff, we've got to be careful. We need the good guys to take a look inside this to make sure there's nothing bad in there. And then we've got other forces at play saying, no. Encryption's encryption. We want to make sure our advertisements are nice and safe and secure. We don't want anybody looking inside. So expect that market dynamic and soap opera to play out over the next 5 years. Regardless of that, though, you're working with an increasingly encrypted world, and that needs to be resolved. It wouldn't be a presentation, would it, unless I mentioned artificial intelligence. So a couple of things to say here with regards to some of the challenges. First of all, I'm going to use an analogy that my COO uses, which I really love. Some of you will have a car that has an automatic transmission. You would not describe that car as being artificially intelligent, though, would you? That's just automation. Let's not get those things mixed up. I often see presentations talking about machine learning and artificial intelligence. What's actually being described is simply automation. It's overdue. It should have happened in this industry a long time ago, and we definitely need it. But that's a different thing to algorithm that is learning all of the time and making decisions on its own behalf. Very different thing. AI is a two-sided coin, just like encryption. There are incredible innovations going on using machine learning algorithm, decision tree analysis and AI, really helping us to try and stay ahead of the game and really improve our cyber defence. But once again, the criminals know this as well. My prediction in the next 12 months, you're going to see some sophisticated mass-scale attacks in the news in the next 12 months that are propagated using algorithm. They are learning using algorithm. They are becoming more targeted because of algorithm. So as clever as we think we are in security research, in leveraging these sorts of tools, the criminals are doing exactly the same thing. So adversarial AI, the business of trying to protect from those very intelligent attacks, is something that we all need to focus on. Let's talk a little bit about this thing. So about 12 to 18 months ago, I saw a huge shift in buying patterns in the typical business in security. And the shift was from the traditional blocking of security and attacks, right? So what I guess we would call prevention. So a shift from prevention to detection. And I remember exactly some of the phrasing that was being used on stage by people like me at the time, which was, the breach is inevitable. And the conclusion from that in many cases was, well, okay, let's stop trying to stop it then. If it's inevitable anyway, what's the point in spending money on this stuff? Let's stop blocking and let's just detect when it happens. Well, let me tell you what happens when you shift fundamentally from doing no blocking at all or very little and invest heavily on detection. WannaCry happens. Let me tell you what detection looks like in the WannaCry world. It looks like 10,000 blue screens. Well done, you've detected it. Well done. Now we're into remediation, hugely costly event. Wouldn't it have been better to block that attack in the first place? So at Symantec, we're really focused on making sure that people's security strategies, the budgets allocated, the resource, time and effort allocated to security architecture is balanced. We need it all, actually. We need to block as much as we can. By the way, there's a good economic reason to do that. It's cheaper. If you manage to block something because it's known and it's a known bad, that doesn't involve any human beings. We've used automation to block it. That's cheap. Cheaper the better, and the more we can block, the better. Of course, though, when those things do slip through, we need to detect. We can leverage machine learning technology to do that. We need to do that. We also need the ability to remediate effectively. So that entire spectrum needs to be catered for. You can't double down on one of those and not the other. The last thing I want to talk about is cloud. We mentioned this earlier. And really, what I want to refer to here is just the usage models that we've seen evolve over the past few years when it comes to cloud infrastructure and applications. Our users right now are all over the map with regards to cloud usage. Some of it's sanctioned by us as businesses, some of it isn't. Some of it is using personal devices, some of it's using company devices. Some of it's happening from the office, some of it's happening from home. Some of it is back-routed through VPN, some of it is direct to net. Some of it is, of course, via these clever new IoT devices that are popping up all over the place as well. This is a huge problem. Getting our heads around the security of our information in the cloud is not just about classifying that information and understanding that it's going to the cloud. The cloud is many, many clouds, and they are being accessed in many, many ways, some of which we're not even aware of. This is a massive strain on security. So, what does this all lead to in terms of design and strategy? So we've been thinking about this for a good few years now at Symantec, and for us it kind of starts here. When I mentioned encryption earlier, one of the things I didn't mention was the fact that the way that we can have a look at what's inside that encrypted traffic, as an example, is using what we call termination points. Termination points in architecture are simply the places where data stops for a while. Sometimes it stops for a millisecond, sometimes the data's at rest for days or weeks or months. But those places for a security architect are really important because they are the places we can look very closely at what's going on inside our packets of data. And despite the 50 years of evolution in IT architecture, there are still only 4 places, really, where we can make use of that kind of a thing. The first one's endpoints. This is where the data lives, of course, most of its life. This is the ultimate destination of the criminal. This is the stuff we need to protect very, very carefully. It's also where we can learn a lot from our data. the proxy. So this is the exit and entrance point for the internet into our businesses. We get the ability to terminate data, do deep packet inspection, decrypt, have a look inside. We can do useful things there. Email. By the way, still the favoured attack surface of the cyber criminal. If we look at the threat landscape of the last 12 months and the previous 12 months and the previous 12 months before that, the vast majority of attacks were initiated at least from a phishing attack, from email. It's also, by the way, a very effective termination point. We can take a close look at data there. Very important. And then lastly, the cloud. We talked about the cloud earlier. With usage of things like aggregation brokers in cloud technology, we can take a look at what's being transmitted backwards and forwards to the cloud. We can stop it if we want to. We can apply information policy to it if we want to. So for our money at Symantec, these are the legs of your stool. If you're going to create a comprehensive security strategy, you can do a lot worse than get these things right. This is where you should start in architecture. The problem, though, is even when you've done that, you'll probably end up with 96 security projects. And that talks to another problem in the industry, whereby CISOs are telling us, we can't see the wood for the trees. Ironically, the very things we're investing in across these pillars here in security are now getting in the way. These security tools, sometimes 50, 60, 70 security tools, are doing the best job they can. They're actually doing the things that the vendors described they would do, but they're all doing it independently of one another. They're all generating a vast amount of log data and other types of data that's being thrown at my security analyst or my service provider, and they can't see the wood for the trees. We miss the breach, ironically, because of the amount of security information we have. Huge problem, very ironic. Huge problem. So what do we do about that? Well, we have to start thinking about connecting them, don't we? We have to start thinking about platform architecture. It's remarkable to me, and I'm old enough to remember ERP, for example. It's remarkable to me that the security software industry has not yet gone through the revolution that the ERP industry did at the end of the 1980s. This is where SAP made its money. Lots and lots of fragmented tools, really not doing us any favours in terms of cost or effectiveness or efficiency. So what happens? We need some gorillas to appear in the market and stand up some platforms that work. Those platforms are modular. We choose the pieces of those architectures that we need to get the job done, but they are platforms, one throat to choke. This needs to happen in security. Absolutely needs to happen in security. And there are going to be a few Goliaths that are going to emerge, I would suggest, in the industry over the next few years. We think Symantec are going to be one of them. Keep an eye on us. Why are we different? Well, we're different because we took a look at this approach. And I'm not going to name names, but some other people have taken a look at this approach over the past 5 years, and they have been unsuccessful. Why? Because when you use APIs to get these 96 products to talk to one another, you end up with a spider's web that is impossible to maintain. So at Symantec, we've spent the last 2 years investing in something else. We've built an open platform. We've worked with industry on that platform. We've worked, in some case, with our competitors on building this platform. And we've created an open integration fabric, a language, a schema, if you will. Now, I haven't got time with the slot now to go into the details technically of this, but what I'm most proud of in the past 18 months or so, in terms of the achievement here, is this. What you're seeing on the screen are the organisations that have gravitated to this platform that we've built. Many of them helped us build it. We've leveraged open standards to allow us to build this platform. Not standards that Symantec came up with, but standards whereby we joined the committee, we influenced where we thought that standard should go, and frankly, the rest of the security industry agree with us. Standards like OpenC2 and TAXI and STIX and things of that nature. And we've built an open framework and an open platform using standards that everybody you see on the screen and others have signed up to. Everybody you see on this screen is part of what we call our Technology Integration Partner Program, and what we experience in every single case is what I refer to as 1 + 1 = 3. You take two great technologies, you put them together, you solve a problem you couldn't solve before. You put two people's data sets together through a shared schema, and you allow the rest of this ecosystem to access that data in a standard way, and wonderful things start to happen. This, I believe, represents radical innovation in the security industry. We are going to see the emergence of platforms. We nearly saw them emerge a few years ago, but not quite. We were too reliant on this API-style development. I think an open architecture, a shared schema, and an ecosystem like this one is going to have the best chance of allowing us to stay ahead of the game in terms of cyber defense. Thank you very much.